Okay, everybody, we're ready to take on our second hypothesis test. And I'll admit the date is incorrect there. It is July 24th, not April 14th. Um, and so, what are we doing? We're opening notebook 15. All right. And that should be baby.csv is the table, not CSY. Sorry about that. We're going to be talking about two sample t-tests. All right. And so what we're going to do is we're going to compare the averages between two groups. Like, for example, we can compare the average birth weight of the moms who are smokers compared to the moms who are non-smokers, right? So we can compare two groups directly to each other. And this two-sample t-test assumes that the samples are independent. In other words, the mom is either a smoker or she's not. There's no third category, right? There's just two possible categories. So that's what we use a two-sample t-test. It's sometimes also called an independent samples t-test. And we'll talk about that more in just a moment. So get notebook at 15 open and get your notes ready. And I will also mention that the two-sample t-test is used quite heavily in the project. So this is the first key video you're going to want to take some good notes and make sure you remind yourself that you may need to look back here at notebook 15 to get help with the project. All right. So this slide or pieces of it were shown in the previous video. And so what are the steps here? All right, so we talked about how to set up the hypothesis, right? We have H sub 0 for the null hypothesis, and we have H sub A for the alternative hypothesis. There are two things that can happen, and based on the p-value, we're going to choose one of two options for reporting our conclusion, okay? So first we simulate the test statistic, and then from that distribution, we calculate a p-value. Now, these two steps go together, and often we can have Python do that in one command. Okay, and last time it was stats.ttest underscore one samp for one sample t-test, right? This is a two sample t-test, but again, a very similar name will work. And so we have two possible statistical conclusions. If p is less than 0.05, remember we said that the standard alpha we use because of the lady tasting tea example with the father of modern statistics, Richard, oh wow, and I can't say his name all of a sudden. Oh, it's not Richard, it's Ronald Fisher. There we go, Fisher. We use alpha equals 0.05, all right? And so if p is less than 0.05, we're going to reject the null, which means we have evidence for the alternative. And if not, if p is greater than alpha or equal to, we're going to fail to reject the null, which means we have no evidence the null is incorrect. This is not quite the same thing as saying that we have evidence for the null, but it's sort of how it works. The correct thing to say is that we have no evidence the null is false. Okay, and then we want to specify our research conclusion, what the evidence suggests is true, okay? And as I said before, we often roll steps 2 and 3 into a single Python step, and it will spit out the test statistic and p-value for us. Okay, and I said this earlier, for the research conclusion, when we reject the null, we have evidence for the alternative, and when we do not, we have evidence, we have no evidence the null is false, okay? And please remember that the p-value is, roughly speaking, the probability that the null hypothesis is true. Again, there's a nuance or two there, but just approximately speaking, the p-value is the probability that the null hypothesis is true. Okay, and we're going to go to the birth weight example that I mentioned earlier. And we've got two groups, right? So we've got one group, it can be the mother smoked or the mother didn't smoke. So we have babies from smoking mothers in one group and babies from non-smoking mothers in the other group. And the null hypothesis is that the averages are equal, right? They're all human pregnancies and humans are born, so why wouldn't the means in the two groups be identical? And then the alternative hypothesis is, hey, there's some difference. Maybe the smoking deal makes a difference. Okay, so let's jump into the notebook. All right, and get this initialized to make sure everything is running. I want you to notice that we now have access to this group stats function. This is also used in the project. Okay, and we'll go over how to do that in just a second. Okay, so we read in the table, the baby.csv table. Okay, and you can see here that we have, maternal smoker, true, false. We're going to be using that one. And we have, the birth weight of the baby, the gestational days of the pregnancy, which we'll look at later. Okay, so smoking and birth weight. So births.select. And all we're getting right now is the maternal smoker column and the birth weight column. Why? Well, it'll make life a little easier if we just focus in on the two columns that have the data that we need for our hypothesis test. Okay? And the first thing we do is this group on maternal smoker, and we see that we have 715 non-smokers compared to 459 smokers. Now again, this is an old study. I hope that if we did this today, there'd be a lot fewer smokers. But this is an old data set. And then group stats. So what does group stats do? Well, I tell it the name of a table, all right, and we just created this smoking and birth weight table, which is here, right? I tell it the name of the table. The second thing I tell it is the grouping variable, and I have to put it in quotes, the column in quotes. So maternal smoker is a grouping variable, and why I'm saying that is there are two groups. There's the true group and the false group, basically the smokers group and the non-smokers group. And then the third thing we put in quotes, is the column name of the numeric variable. Okay, and then what do we get? This is cool because when I enter this, and what does it, doesn't like group stats, which is strange since it's right here. Ha, there we go. Sorry about that. And what we're looking at is the means of these two groups, right? If you just look right in here, you can see that there's about a 10-ounce difference between the average birth weight for the non-smokers. That's false, right? So 123.1. And the true, that's the smokers group, which is a little less than 114. Okay, so there's almost a 10-ounce difference between the two groups. Now, looking at the standard deviations, we're not sure how significant this difference is, but we can calculate it, right? That's why we're going to run the hypothesis test, the two-sample t-test. Okay? And by the way, these are the two samples, right? The false group, which is smokers, and the, non-smokers, and the true group, which is the smokers. Okay. So preparing the data. Now, the problem is that the test that we're going to run, it wants arrays. And we just have columns, right? I mean, we just have a table. So everything we've done, even though we've got a hold of it, we just have a table with the two columns of data. And we need arrays. Okay, so that's what this is doing. Okay, group one. Okay. And notice we do the dot where maternal smoker is false. So these are the non-smokers. And notice that we do column one. Why? Well, remember that column 0 will be the first column. The computer starts counting at 0, right? And so birth weight is column 1. It's the second column when we look at it. But again, remember, the first column, according to Python, is called column 0. So column 1 is actually the column that we want. And notice that everything else in the second line here is the same, except that we do comma true, right? These are the smokers. And we do column 1. Okay, now labels, this is going to be, this is going to help here in just a second with these box plots. It's going to label them so we can tell which is which. And notice that we put non-smokers first. Why? Well, that was group 1, the non-smokers. All right. And then we put a title in. And then we leave all this stuff alone, and when we run it, we do in fact get this side-by-side box plot, which shows, and let me move up just a little bit. I know we can't see the top of that left-hand graph, and I apologize for that, but we can see that the mean, okay, so the 5-number summary is the minimum in Q1 and the median in Q3 and the maximum, right? But the orange triangle there, or yellow, I don't know exactly what color it's going to show up on your screen, but that triangle is where the mean is, okay? But on both graphs, we can see that the mean is approximately there on the median bar, so we can kind of see easier where the mean is because it's so close to the median, and we can tell that the two look distinctly different, okay? It appears that for the non-smokers, right, that this is a little higher. Okay, so this is a good thing to do with two-sample independent t-tests. Why? Well, we're trying to compare the groups, but we got to know if there's a difference, right? We're checking to see with the group stats function and with the box plots, the side-by-side box plots, we're looking to see if there's an association there. And the association appears to be that the average is higher for the non-smokers. So we're going to run the test. Okay? And again, we're using the scipy.stats, but we've imported it, and its alias is stats. So the correct way to run the test is stats.ttest_ind. And again, why is it ind? It's because this is an independent samples t-test. A two-sample t-test assumes that the samples are independent. Okay? Group 1 is the array data that goes in first. Group 2 is the array data that goes in second. Remember, it is non-smoking moms first and smoking moms second. And always we're going to use this option, equal variance equals false. It spits out the test statistic and the p-value. Now, the p-value, this is a big mistake that a lot of people make. They say, oh, the p-value is 2.656. That's bigger than 0.05, so fail to reject the null. But always check the end of the number. Okay, it's actually scientific notation, which is this number, 2.656 times 10 to the negative 17th, which is actually really, 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 really close to 0. Okay, and this is extremely small, as you'll see written right below there. So since it's less than 0.05, we're going to reject the null. So let me ditch the ink and jump back to our notes. And you can see the same result. All right, we're going to use the two-sample t-test. And I mentioned this, right? We have the non-smoking moms in group 1 and the smoking moms in group 2. And we did the side-by-side box plots, as I specified, to check for associations within the data. It did, in fact, appear that, and I am sorry, I'm going back, the birth weight example. And, okay, the same thing is true, but we seem to have jumped ahead, and so I am going to pause. Sorry. And go back to notebook 15, right? And what do we get? We get p is less than alpha, so we reject the null, which means there's a significant difference in weights for babies based on whether their mothers smoked or not, right? So jumping back in, right, we have rejected the null. We have good evidence the null is false because that p-value is so close to 0. So our real-world conclusion is that there's a difference in the group means. Okay, and based on the box plots, not only is there a difference in group means, but it appears that the average birth weight is higher for the babies in the non-smoking group. Okay, and remember from the last time when we're using this birth weight example, we're using birth weight as a proxy for health of the child, health of the baby. Okay. Again, it's not a perfect measure. You know, it is a problem if the baby grows too large in the womb. But again, this is an older data set, and that's the best thing we can do to get a proxy measure, a numeric measure for the health of the baby. Okay. So the next example is from the same data set, but gestational days, and we have the exact same thing. We have the average gestational days from the smoking group, and in the null hypothesis, we have that that should be equal to the average gestational days in the non-smoking group. Now, this is another measure of health. They're assuming that you want to have more gestational days because fewer gestational days, you have a higher chance of being premature and the problems that come with preemies. And they're saying, hey, that there's fewer gestational days in these smoking moms' pregnancies than there is in the non-smoking moms' pregnancies. And if that's true, then it means that there could possibly be a problem, um, you know, with the baby being born too early. A few days before your due date is not a bad problem, but if we're 2 or 3 weeks ahead of the due date, then we could have some problems, potentially some health risks to the child. So that's what we're checking on in this second hypothesis test. So jumping into the jumping in here, and I am sorry. This reporting out, this is finishing up the birth weight examples, and it says what we said there. Sorry about that. So birth weights by mother smoking status, you'll notice that now we've changed group 1, and now we're looking at the column 1. Let's see. Birth weights by, come on. I am struggling, and I apologize. And this is still the birth weight. There's a couple different ways that we have done the birth weight example, and now they're doing it yet another way, and I'm going to have to apologize. And so let's do this. I'm going to come up to the last place we were. And so this is the birth weights by mother smoking status. And you know what? I am just going to open up a couple of things right here. So let's do this group stats. And if we go to the, what's the original name? Isn't it baby? Group stats.baby dot, I have to go all the way up and find this data. So I'm going back to this. Oh, it's called births. And we're going to do gestational days and maternal smoker. Okay, so group stats, it's going to be births is the name of the table. So you put the name of the table in first. Again, I'm showing this because this is used on the project. And then I'm going to put quotation marks and gestational days. And then smoker status, right? I believe is with a space. Let me try that. And which label did I get wrong here? Smoker status is not in the table. So I'm going to zoom right back up and see what the name of this column is. Maternal smoker. Okay, so I copy pasted that maternal smoker. I'm going to come back down here to my spot. And instead of smoker status, it was maternal smoker. Okay, so I'm doing group stats. And it does give me a little bit of a baby error there. Why? Well, it's got lots of different, because I did them backwards, right? I need the grouping variable first. So maternal smoker, that's the true or false. See, it'll do a numeric variable first, but it gives me a table with every single value of gestational days. All right, so what I needed to do was put maternal smoker first, the grouping variable, the numeric variable second, and there we go. There's two groups. And we see that there's a slight difference in means. Are we sure there's a difference here? No, we're not. Um, but we can, in fact, do the hypothesis test anyway and check. Okay, but there is a little bit of a problem, right? We need array data, right? So let's do smoker for the smoking group. So that's going to be births.where, and this will be maternal smoker. Smoker is true. And again, we're going to use dot column. But here we need gestational days. And again, I'm not sure which number column that is, so I'm typing it in. And let me just do smoker and print it out, and we'll see. There we go. So we get an array of these number of days, and they make sense, right? Because 9 times 30 is 270. So these array numbers do appear to be in the correct range, right? They're the right number of days. All right. And then I'm going to make a non for non-smoker group. And I'm just going to copy paste the line above it. Why? Well, we have pretty much everything we need, except we turn the true to false. Sorry, capital F, false. Okay. And so now we have array data, right? We have smoker and we have non. These are two arrays that can go in. So let's do it. So we're going to do stats.ttest_ind, and we can do non, smoker. And why am I doing non-smoker? Well, because we did the non-smoker group first up above. So I'll just keep it in the same order with non-smokers first and then smokers second. And then this, equal var equals true. False. Boom. And we get a p-value. And we reject the null. So the p-value is 0.035, which is less than 0.05. So the p-value is less than alpha, so we reject the null. What do we know? Well, if we go back here, if we go back here, right, the gestational days example, right, we reject the null, right? And therefore we have evidence that the smoker group has, on average, fewer gestational days than the non-smoker group. And again, that's another proxy for the health of the baby. All right, they're saying there's a bigger chance of premature birth in the other group. Okay. And again, the code is just what I showed you. Showed you the p-value. Okay. And this is what we just said about the result. Now, recapping, what are we doing here, right? I just want you to know this stats test underscore ind, and we always are going to use the equal underscore var equals false. Why is that? Well, there's two ways to do this. We can assume the standard deviations in the two group are identical, or we can assume they're not. The more correct assumption, the vast majority of the time, is false. So that's the one we're going to use. Okay. And again, we're just comparing p to alpha and rejecting the null when the p-value is smaller than 0.05. Rejecting the null, right, means that we have evidence for the alternative. And these two sample independent t-tests are going to be the same all the time. They have the same basic setup. There's two groups in the hypothesis, and they're run the same way, and we report out the same way. And again, these are used a lot in the project. So please, if you didn't understand everything, go back and watch the video again, and good luck. If you have any questions, please see me on Teams.